A and AS level mathematics. Lesson 22, we're going to return to algebra, and this is going to be algebra part 10. And in this session we're going to be looking at the factor theorem, algebra division, solving cubic equations, and the remainder theorem. So let's start with looking at the factor theorem. When we have a polynomial like this cubic and we want to factorise it, we have a bit of help with the constant term. In other words, looking at this example, the constant term is the term at the end, which is the 18. And the factors of 18 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. They are the factors of 18. Now, assuming that the polynomial does in fact factorise, it means that one of the factors must be at least either x plus or minus 1, or x plus or minus 2, or x plus or minus 3, and so on. There is a quick way of finding out which of these will be a factor. It's called the factor theorem. So we substitute our factors of 18 into the polynomial and see if any of them result in being 0. Okay, let's use the factor theorem. We can write the function like this. The function of x is x cubed minus 2x squared minus 9x plus 18, and substitute the value of x equals 1. And if we substitute the value of x equals 1 into this cubic, we get 1 cubed minus 2 1 squareds minus 9 multiplied by 1 plus 18. That is 19 and minus 11, which does not equal 0. Now let's substitute the value of minus 1. X equals minus 1. Minus 1 cubed is minus 1. Minus 1 squared will be plus 1 multiplied by the minus 2. Minus 1 multiplied by minus 9 will be plus 9, and plus the 18. That's minus 9 and plus 27 does not equal 0. Now let's try substituting x equals 2. X equals 2 when cubed is 8. X equals squared, 2 equals squared is 4, 2 4, so that's minus 8. Minus 9x means minus 9 times the x value of 2, which is 18, minus 18, plus the 18, that does in fact equal 0. So, because x equals 2, when substituted into this cubic, results in 0, it does mean to say that if x equals 2, then x minus 2 must in fact be a factor of that polynomial. Now we could continue to substitute in the other values of x equals minus 2, x equals plus 3, x equals minus 3, x equals plus 6, and so on, and again seeing if the result is 0. And that will enable us to find another factor. Let's have a look at this. Factorise this expression by using the factor theorem. So looking at this cubic, constant term 16, let's write down the factors of 16. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. So let's see what happens when x equals 1. So we substitute x equals 1 into here. 1 cubed, 1 squared multiplied by minus 4, minus 4 times 1 plus 16. That doesn't equal 0. Let's try x is minus 1. Minus 1 cubed will give me minus 1. Minus 1 squared is plus 1 multiplied by the minus 4. Minus 1 substituted into here will be minus 4 times minus 1, which is plus 4, plus 16. That doesn't equal 0. Now let's try substituting x equals 2. 2 cubed is 8. 2 squared is 4, minus 4 times 4 is minus 16. Minus 4x is minus 4 times 2, which is minus 8, plus 16. That's 0, that's 0, we have 0. This means to say that when x equals 2, the polynomial comes to 0. That implies that one of the factors is x minus 2. But we're asked to factorise this theorem, so let's continue. Now let's put in x is minus 2. Minus 2 cubed is minus 8. Minus 2 squared is plus 4. Multiplied by that minus 4 will give me minus 16. Minus 2 substituted into here would be minus 4 times minus 2, which is plus 8. Plus the 16. That again comes to 0. So in other words, x equals minus 2 results in 0, implies that x is plus 2 is another factor. Now let's try x equals 3. In other words, we will be working out when x equals 3. So you get 27 minus 9 4 9s 36, 4 3s minus 12 plus 16, that doesn't come to 0. Now let's try minus 3. When x is minus 3, that will be minus 27. That will be plus 9 multiplied by the minus 4 is minus 36. That will be minus 4 times minus 3, which is plus 12. That doesn't come to 0. Now let's try putting in 4. 4 cubed is 64. 4 squared multiplied by 4 is 64 minus 64. 4's a 16 minus 16 plus 16, that does equal 0. So in other words, when x equals 4, this comes to 0, which implies that, I'll better put it here, run out of room, x minus 4 is a factor. So we have in fact managed to factorise this cubic and worked out that it is x minus 2 multiplied by x plus 2 multiplied by x minus 4. So we've been able to use the factor theorem to factorise a cubic.